So, welcome back. Let's take a look at the question today. This one's not meant to be tricky at all. We're just identifying action-reaction pairs for each of these four things. How about I start by doing the first one, and you can tell me what the other three are. So, an action-reaction pair is like when a ball hits the wall, and then the force of the wall on the ball is equal to the force of the ball on the wall. So the same thing's true for these. So like the first one, a boy takes a step, so I'd probably say the action-reaction pair would be the force of the ground on his foot, and that's equal to the force of his foot on the ground. So a snowball hits a girl. What's the action-reaction pair there? Force of the and the force of the exactly. So those things will be equal. The third one, a baseball player catches a ball. What's the action-reaction pair there? The force of the force of the ball on the player and the player on the ball. If you want to get specific, you could talk about the force of the glove on the ball. Either is perfectly acceptable. And wind strikes a window. The force of the on the is equal to the exactly. Force of the wind on the window is equal to the force of the window on the wind. I'll give you a bit of time to write all that down. Nothing too extraordinary. And I know I reminded you guys of this yesterday, and again, for those of you watching at home, don't forget that your final exam is based on these questions. The final exam in this class are these questions in multiple choice form. Not every single question that you have will be on there. Basically, it's just the ones that I could put into a multiple choice question. But you do want to make sure you have all those questions and answers available for you to study. So it's always a good idea to check yours with someone else's in case you missed one or two in there. So be sure to take care of that if you might have missed a couple. All right, worksheet number 4. What should we go over from worksheet number 4?
I feel like I did it.
Feel like you did it wrong?
Well, because I felt like I would repeat the same stuff. Like, it was like the same.
Sure. Yeah, I mean, that's mostly what this is. It's pretty much the same scenario for each one. I mean, they change velocity and acceleration. They change the masses sometimes. So mostly what changes in your answer is not the directions, but it's just how big your arrows were supposed to be. And again, I don't find that as important as actually drawing the arrows in the correct directions and having them labeled the right way. But I think yesterday we did number 2, right? Okay, so let's pick at least one more from the first page to do, and we'll see how it matched up with what you have. How about number 4? So number 4, we've got mass B, and that is rather large. And it's got a pretty big force of gravity, and therefore a pretty big normal force. Block B is being pushed to the left by block A. So we've got a force going to the left, and I'd call that the force of A on B. So that's my fab force right there. And of course, going to the right is friction. Now, in terms of this friction, if I really want to be specific on how long its arrow should be, how long should the friction arrow be compared with the force of A on B? Bigger, smaller, the same size? For block B. Yeah. Good guesses. They're both wrong, actually. That's okay.
Equal.
Equal, yes. And the reason they're equal is because this scenario has a constant velocity. And if here's a good try. If your velocity is not changing, that means that the forces have to be exactly opposite each other. So if my velocity remains the same as this block is moving, that means the forces left and right must also be the same. So my friction is going to be the same length, if you want to get that specific. This isn't the sort of thing that I'm going to take itsy-bitsy points off for when we come to test time. But just, that's how it should be if you're being really specific. Of course, if it was speeding up, then force of A on B would be bigger than force of friction. That's how these arrows would be different if you have that changing acceleration.
Wouldn't it be like basically equal for all of them then?
What would be equal?
Besides like the pulling, like if you're pushing it into the box, or never mind.
That's okay. I think where you were going with this is probably 100% true, and we'll get to that after I finish block A here. So block A is smaller, a little bit more adorable. Gravity, therefore, will be a little bit smaller, as will the normal force. Boy, it's heating up in here pretty quick, isn't it? No, you guys are okay with the temperature? All right. So those are our vertical forces. Block A, as it's being pushed to the left, is partially being resisted by block B. So block B has a force that is going in the opposite direction of the motion, which in this case would be to the right, because everything's moving to the left. So the force of B on A is going to be pointed to the right. In addition to that, because it's moving to the left, we're going to have some friction to deal with. And friction always goes in the opposite direction of motion, which again is to the right here. The only other extra force that's involved in this block is the force that's from the actual finger that's doing the pushing. It's applying a force to the left, and so we would call that FA, applied force. And again, if we really wanted to make sure our arrows were the right sizes, because the velocity is not changing, this arrow should be the same size as the combination of these two. And that would be number 4. Now, what about the actual question it's asking about number 4? It says, the choices for all questions are as follows. The force of A on B is greater, the force of B on A is greater, or C, the force of A on B is equal to the force of B on A. So which of those three is going to be the answer to this question? Exactly, as Brooke is saying, letter C. And the reason for that is because Newton's third law plainly tells us the force of B on A is always equal to the force of A on B. So what does that mean for the answer to every single other question on this worksheet? It's C. The answer is always C.
That's what I was saying before, like, shouldn't they all be C?
They are. And that's where I thought you were going with that, but I didn't want to give that answer right away. So good job on that one for sure. Yep, all of them should be the letter C. Every time, all the time, the force of one object on another will be equal to the force of the other object on the first one. Yes, Val? Aren't all the same what? The square thing? I'm sorry, I'm having trouble just understanding what. It's okay. Yeah.
Are they like sort of the same?
Yes, yeah, absolutely. So most of your answers on the front page are going to look extremely similar to this. Arrows in the same directions and everything. The main difference is, like, if B was smaller, like in problem number 2, you would just have a smaller force of gravity and normal force. But everything else would be the exact same.
Yeah, that's what
Yeah. So almost, when you're going through this, you might think that this can't be that easy, it can't be that simple, but it actually is. Same arrows, same directions. It's just if you're being specific, some of these arrows will be larger than others. So let's take a look at one of them on the back, and then I think we can call it a day with this worksheet. Anyone in particular you'd like to talk about? Yes?
I was gonna ask for the bathroom.
Yeah, you can do that.
No, it's not allowed.
How dare you? There you go. Yep. Last call. Anybody have a preference on which one to do? Yeah, one on the back side. 10 sounds like a really good answer. Let's see what we can do with problem number 10. So once again, block B is a fatty. Much larger than block A.
Wait, did you say block A is a fatty?
It's big boned.
Big bone.
And so, because of block B's girth, it has a larger force of gravity and normal force than block A will. Horizontally speaking, a couple things are happening with block B here. First off, it's being pulled to the left by an actual string, and this string that's being pulled to the left with is not attached to block A or anything. It's just straight up pulling block B. So we're going to call that a tension force. Now, to the right, we've got several things going on. Again, there's friction that we have to deal with. Friction is always opposite the direction of motion, which in this case is the motion's to the left, so the friction will be to the right. So we've got some friction going that way. And of course, if you're block B, with these force diagrams, if you have trouble drawing it, just picture yourself as the block. If you're block B, you're being pulled two ways. You've got tension force pulling you this way to the right, and you've got friction pulling you this way, and that string attached to block A is also pulling you to the right. And so, if that's the case, we have another force in that direction. Of course, we'd call this the force of A on B, because as B is being pulled, it can feel that resistance from block A. Then there's block A, much smaller, it's in better shape. You've got a smaller force of gravity, smaller normal force, and in terms of the horizontal forces, if you think of yourself as being block A, you've got several things going on here. Number one, you're being pulled to the right because you've got a string that's attached to block B, so we would call that the force of B on A. And because there's friction, friction is going to the right. And again, in terms of these arrows and their length, in this question, we've got a constant acceleration to the left. So what that would mean, if you're being detailed about it, is that the length of the arrows pointing to the left on both of these boxes ought to be bigger than the combination of all the arrows going to the right. So if I was being real specific, I'd make sure that this tension force arrow was bigger than the combination of these two, because those are the conditions you need for an acceleration to happen. Yes?
On the test, are you going to want us to make the arrows bigger and smaller?
Now, if I do something like this on the test, I just want to have the right arrows in the right directions. But yeah, same thing for block A. If it was accelerating, the force of B on A should be bigger than the force of friction. And just like all the other answers on this piece of homework, the correct answer is C. The force of A on B is equal to the force of B on A. And there we go. Yes?
Is the whole thing C?
Yes. Every single one is letter C. I'm sorry if that made anybody think too hard on this than you needed to.
It kind of made me.
Yeah, it happens. Letter C. Any last questions on worksheet number 4? Okay, I'm going to come around and grab that from you then.